Section 7.5 is on parallel lines and angle bisectors and how we're going to use those in similar triangles. So we're going to be using special proportions such as the angle bisector and parallel line proportion to solve problems. So the triangle proportionality theorem is if a line parallel to one side of the triangle intersects the other two sides of the triangle, then it divides those two sections into equal proportions. So basically what that means is RT over QT is equal to RU over SU. So an example, we could have 10 over 5 and 12 over 6. So if we had this and we set up our proportions, we would do 10 over 5, which we know simplifies to 2, and 12 over 6, which also simplifies to 2. So the ones that are on the same side go together in the same fraction when we're working with the parallel lines. The converse, or the opposite of that, is also true. So for example, if we were told that RT over TQ and RU over US were proportional, then we would know that QS is parallel to TU. So we would know that those were parallel to each other. Now we can use that information to solve for different values. So in this example, in the diagram, they tell us that QS and UT are parallel. They also tell us RQ is 10, RS is 12, and ST is 6. They want us to find QU, so I'm going to put an X there to represent that. Now, because these lines are parallel to each other, we are going to set up two fractions that are equal to each other to solve. And if they're on the same side, we know those go together. So we'll have 10 over x equals 12 over 6. Then we can cross multiply to get 12x equals 60. Divide both sides by 12, and we will end up with x equals 5. The next theorem that we're going to go over is the parallel line proportionality theorem, which is very similar to what we just went over with the triangles. So for this one, if three lines, which are parallel to each other, intersect two transversals, then they divide the transversals into equal proportions. So remember, transversals are the lines that are not parallel to each other. So in this example, L and M, those lines are transversals. So if we have R, S, and T as parallel lines, and they intersect line L and M, then we know that the length of UW over WY is going to be equal to VX over XZ, because they're going to be proportional to each other. And we're going to go over an example of this in a moment. Before we go over an example, another theorem that we're going to use is the angle bisector theorem. And this one is if a ray bisects an angle of a triangle, so remember bisect means it cuts it in half, then the ray divides the opposite side into segments that are in equal proportion to the lengths of the other two sides. So what that means, if we have X and Y here and A and B here, because this is angle bisector, the side it cuts in half is going to be equal to the proportion of the other two sides of the triangle. So X over Y would be equal to A over B in this example. And if we were using the names of the segments, AD over DB would be equal to CA over CB. So now we're going to use these in examples. So in this one, a farmer's land is divided by a newly constructed interstate. The distance in meters are shown. They want us to find CA between the north and the south border of the land. So we're trying to find this whole distance here. So I'm going to represent that by X. Before we find that, we need to figure out what this segment is here. We do have parallel lines, so we can use our parallel line proportionalities to solve for our missing value. The two sides that we have on the left are 2,000 and y. One fraction will be 2,000 over y equals, and then the second fraction will be our numbers on the right, which is 2,500 over 3,000. Now that we have this, we can go ahead and cross multiply. We'll have 2,500y equals 2 times 3 would be 6, and then we have a total of 6 zeros that we need to add. Then we will go ahead and divide both sides by 2,500. Cancel out some zeros. And do some long division. 50. Okay, so y is going to be equal to 2,400. And remember, we were looking for the full distance, which we represented by x, which is going to be equal to the length of 2,000 plus y. And we know that y is equal to 2,400. Now that we have that, we can get our final answer of 4,400, and this is going to be represented in meters, which will give us our final answer. Our next example uses our angle bisectors because we have those two congruent angles. So remember, the angle bisector talked about the two lengths that are formed because of that bisector. We know the full length from D to F is 14, and we know that this one small portion is X. So to find the other part, we are going to take 14 minus X. And that's going to be the second length we need. So now we're not even going to worry about this 14 there. We're done with that one. So we're going to use, jumped ahead. The angle bisector theorem. So remember, we're going to take these two sides that the angle bisector form, write them as a ratio. And that's going to be equal to the other two sides of the triangle as a ratio, which will be 8 over 12. Then once we have that, we can go ahead and cross multiply. And again, don't forget our parentheses here around the 14 minus x. And that will be equal to 12x. Now we can distribute. And if we take 14 times 8, 8 times 4 is 32. 8 times 1 would be 8, 9, 10, 11. So we're going to have 112 minus 8x, because don't forget we have to multiply the 8 by that as well, equals 12x. Go ahead and add 8x to both sides. And then we will divide by 20. And we will get 56 equals x. that would be our final answer. Our next example, again, we are going to be looking for the length of AB, and this one is our parallel line proportionality that we can set up. We can do 24 over 32, and remember the ones that are on the same transversal are going to be the ones that go in a fraction together. And then over here we have our x and 27. And because we put 24 on top, we're going to put 27 on top of our second one because they're in between the same parallel lines. Now we can go ahead and cross multiply. And we'll take 32 times 27. 22, so that would be 4 and 6. Add these together. And we will get 164. Then we will divide both sides by 24 to figure out what our x value will be. Oh, that's not what I wanted. 24, 48. Three, 72, 4. And then 24 would go into 144 6 times. So our answer for x for this one will be 36. And remember, you can use a calculator for your final answer, or to get your final answer, and then you don't have to do the multiplication and long division. All right, our next one. This is our last example for this section. We have an angle bisector again, because these two angles are congruent to each other. And we're looking for AB. So remember, we take the two segments that are formed by that angle bisector and write those as a fraction. Then we take the other two sides of the triangle and write that as a fraction as well. Now, you'll notice our first fraction was 1 over 1, which, because they're both the same, means that the other fraction, the top and the bottom, will also have to be the same, making x equal to the square root of 2. If you do not notice that, you can still cross multiply to get your answer, and we would take 1 times x, which is x, and 1 times the square root of 2. And you'll see that we get the same answer for that. So if you have any questions on this, just let me know, and I will get back to you on those.